In addition to scouting matches, some teams also go to the pits to take notes on the physical attributes of the robots. Pit scouting data is an entirely different breed of information. Most pit scouting data is qualitative, not quantitative. However, by creating figure of merit equations, we can start to rank these teams. In this video, we will incorporate some of our pit scouting data into Tableau. To do that, we will learn how to link multiple sources of data into one workbook. Filtering robots by pit scouting data is very useful if we are looking for a specific feature that we might really want in our partners, such as a blocking mechanism or a very strong drive base. We will also learn how to apply what we have learned about analyzing pit scouting data to a few other fields. By the end of the video, we will have made a sheet that will help us rank the pit scouting data. The first step towards analyzing our pit scouting data is to import it into Tableau. The most simple way to connect to our pit scouting data is to connect to more data. To connect to data, it is exactly the same as when we import our data the first time. In this video, our pit scouting data is located in the same Microsoft Access database as our match data. However, it's in a different table. So to connect to our pit scouting data, we once again select the file type, find it, and connect to our table. Just like before, we are going to import all of our data. Now, notice that there are two data sources up here, instead of just one. We can switch in between them by clicking. Once we drag team number to dimensions, Tableau should automatically start linking them together. A way to check to see if Tableau has linked something is to go to a different data source and drag on team number. Then, go to the secondary data source and see if this link thing is there. If the link is not there, then we need to manually connect our data. To manually connect our data, go to the Data tab and Edit Relationships. Then we can make a custom join based off of team number being the same as team number in both databases. One of the advantages of using Access is we can use a slightly more advanced way of joining our data sources. Before we start, let's remove this new pit scouting data that we connected to. Then, to import our pit scouting data, we can go and edit our connection to our data. Because both of our tables are in the same database, we can connect to both of them at the same time by changing the connection from a single table to multiple tables. Now, let's add our pit scouting data. After we select which table we'd like to import, then we have to join them together. Currently, they're joined by their ID fields. Because of the way we have set up our database, match ID is not the same as pit scouting ID. Something that is the same in both databases is team number, so let's link them together by that. Then, we need to change the join type from an inner to a left because the left data source is much more important than the right one. Now, notice that there is still only one data source, but now it's divided up based off of which table the data comes from. So let's make a very simple way of organizing our pit scouting data. The most simple and easy way of organizing pit scouting data is to drag on dimensions in the order that we think they're the most important. For instance, let's say that we think first motor type, then wheel type, then if they have a transmission is the most important. Then we can reorder them. For instance, we probably want teams with a transmission to be above teams without a transmission. Likewise, we probably want teams with 4 sims to be above teams with 2 sims. Now if we go down the list, our teams are roughly sorted by what makes them the most powerful. One of the problems with using this method is inflexibility. For instance, a team with 2 sim motors will never rank as high as any of the other teams, no matter how good the rest of the bot is. If we want a more flexible way of ranking our pit scouting data, we can start to make figure of merit equations. A figure of merit equation is where we assign worth to all of the different types of wheels or transmissions or motors. However, making a figure of merit equation for every single combination of pit data would take an incredibly long time. To make it simple, we make a figure of merit equation for each dimension and then add them all together. Let's go through the process of making a figure of merit equation for wheel type. Back in an earlier video, we used the case function to turn starting location into coordinates. This time, we will be using the case function again, but instead of assigning coordinates, we will be assigning values. First, type in the word case. Then, find wheel type. Now, we put a when statement for each different type of wheel. For instance, when we have high traction wheels, then let's assign it 3 points. When we have a kit wheel, then 2 points. When we have mecanum, then 0 points. And when we have omni, let's pretend that our team really doesn't like omni wheels, so let's give them a negative 2 points. By assigning values to these outcomes, we can start to rate how much our team likes or dislikes these features. If our team really likes a feature, we should give them a very high rating, and if our team really doesn't like a feature, like omni, we should give them a penalty. To save time in this video, I've already made a figure of merit equation for motor type, transmission, and collecting method. Now, let's combine them together to make one overall pit figure of merit equation. The overall pit figure of merit equation simply adds up all of the smaller figure of merit equations. Now, if we wanted to sort by figure of merit equation, we could turn the figure of merit into a dimension and then drag it to the front of the row shelf. Then, sort from greatest to least. Now that we have our pit scouting data in Tableau, it's usually good to drag our team names onto either the text or the tooltips shelf. By having team names in our view, our data becomes more clear to outsiders or people just barely glancing at our data. Our figure of merit equation is also useful in other places. For instance, let's make a very simple graph of total score by team number. We could use a pit figure of merit equation to color it. Now, the best dry bases are colored darker than the rest of the robots. This sort of data may be very useful during alliance selection. Something else that teams often like to know, but it's hard to graph, is reliability. Reliability, like tribe base strength, is also a very complicated field to graph because not all of its components are numbers. Reliability includes fields such as deadbot, no-show, and yellow and red cards. All of those fields are booleans, the type of data that is created when we use a checkbox back in Access. We can't get a count off of them, unless, of course, we make a calculated field. Let's make a calculated field to find the number of yellow cards committed during a regional. Let's label this one yellow count. Basically, if yellow card is true, we want this calculated field to return 1. After we do that, we could find the sum of this calculated field to determine how many yellow cards a team committed during a regional. We can do this using a case statement. Case yellow card. When yellow card is equal to true, then 1, else 0, end. The else statement can be used in case functions. The else statement means that if yellow card does not satisfy any of the above conditions, then to return that value. However, there's a faster way of doing this. We could use the if statement. The if statement is slightly different. We can simply write if yellow card, then 1, else 0. The easiest way to explain how if functions work is by reading them out loud. If yellow card is true, then this function is equal to 1. Else, if yellow card is not true, this function is equal to 0. When using if statements with non-Boolean fields, we can instead put a logic statement on the first line. An example logic statement would be if tally score is less than or equal to 30. These logic statements are written exactly like an inequality in a math problem. This saves us a lot of time. Because this is a little bit new, because the if statement is new, let's practice it one more time by making a red card count. If red card, then 1, else 0. This format of if statement will work on any Boolean. Because making the calculations for deadbot and no-show are just more of the same, I have already created them. Now, let's start adding together all of our reliability fields to generate reliability. The calculated fields that we have written have helped turn our Boolean values into counts. Now we can take those counts, scale them, and add them together. This is very similar to what we did to find teleop score and autonomous score back in an earlier episode. First, we have to insert all of our fields. Now we scale them depending on how many points we think it's worth. Then we add them all up. We can then take reliability and drag it on the color in the same way that we did with pit figure of merit equation. Alternatively, we could simply make a bar chart of reliability. If we don't want our bars to be pointed in the wrong direction, we can reverse the x-axis by right-clicking on it. Just like before, let's drag team name onto label. It appears that Team Crowded Bison is not a very reliable team. Most teams have a very hard time integrating their pit data smoothly into their normal scouting data. Tableau helps make that integration very simple. The second method of using figure of merit equations that we learned is just as amazing. By using this technique, we could graph anything we want as long as we collect data for it. For instance, we could graph how easy teams are to work with. We could do this by counting the number of times they bump the robots in our alliance, and maybe have our drive team give them a rating after each match. The data that we graphed in this episode is just one more way to get an edge at a competition. Thank you.